Alrighty, what we're talking about today is the three energy equations. So these three energy equations are found on page 3 in our reference packet. I've already written them down up here along with some notes. So let's look at each of these equations and talk about what it means. So these are our three Q equations, or energy equations. Q, the unit for Q is joules. Joules is a measurement of energy. So for the first equation, Q equals mCp delta T. M is going to be our mass. So mass is important. Cp is specific heat. How do you find the specific heat? The specific heat will normally be given to you. Down below I've written the specific heat for water. Notice how the specific heat for water changes as each phase changes as well. So solid has a completely different specific heat than liquid. Then delta T. Delta T is very, very important. Delta T means change in temperature. So whenever we have a change in temperature, we're going to use this first equation. Second and third equations are very similar, just one slight difference. Q equals mHF, heat of fusion. Heat of fusion is talking about when we're melting or freezing a substance. And then the third equation, Q equals mHV. HV stands for heat of vaporization, and that's when we are condensing or evaporating. One thing that you should notice about 2 and 3 is that there's no temperature. There's no temperature because whenever we have a phase change, it takes energy to do a phase change, so temperature is going to be constant during a phase change. I also have written the important units for each and the important numbers where you find these constants, thermodynamic constants. We find those on page 1 in our reference packet. So they're on the front. Now, let's look at the problem. How much energy is required to turn 5 grams of ice at negative 5 degrees Celsius into steam at 110 degrees Celsius? So we have to break this problem down. We cannot just use equation 1, because we have phase change. We go from ice to steam. Remember, the heating curve of water looks something like this. Here's our heating curve of water, where we have solid, it's melting here, liquid, and evaporating here or boiling, and then our gas. So we have to break this question down into 5 different segments. So I'm going to do all 5 of them, and then we have to add them up to get the total. So I'm going to start with the solid. So the first thing we have to do is we have to go from negative 5 degrees. We have to get this ice to melt. Well, ice will melt at 0 degrees. So that's our first kind of big piece of information. We start at negative 5 degrees Celsius, melt at 0 degrees Celsius. Start to melt. So we're going to use the first equation for the first part. Q equals our mass. The mass in this problem was 5 grams, so we have Q equals 5 times our specific heat, Cp. Now, which specific heat of water do you use? Well, we're going to use the solid one, 2.05 joules per gram degrees Celsius, because that's the specific heat for ice. And this is 5 grams. I forgot my units. Don't forget your units. 2.05 joules per gram degree Celsius. Times our delta T, our change in temperature. If we look back at our rough graph, you'll notice that we went from negative 5 degrees to 0 degrees. That's our change right there. Now you can do final minus initial. That's how you calculate the delta T. So we would have 0 minus negative 5 degrees Celsius. Put that in parentheses because, if you guys would, please excuse my dear Aunt Sally. Now, we plug this into our calculators and we get a number. as we're looking at the units, notice that we have grams on top here, grams on bottom there, so grams are going to cancel out. We have degrees Celsius, that cancels out. We can just plug it into our calculator, and our unit is going to be joules. So we do 5 times 2.05 times parentheses 0 minus -5. And we get 51.25 joules. So, come back here. The amount of energy right here was 51.25 joules. So that's the first thing we have to do. The next thing we have to do is we have to figure out the energy required for this 5 grams to fully melt. Because whenever we melt, we have a phase change, and temperature is going to remain constant. So for this one, we're going to use the second equation, Q equals mHf. So let's use that. Where Q is our energy. Our mass does not change, so we use 5 grams times heat of fusion. We look on our reference packet, or in this case right here, we're going to use 334 joules per gram. My grams cancel out. We plug it into our calculator. 5 times 334, and we get 1,670 joules. So that's part 2. That's the melting. So we know how much energy it requires to melt it. And that was 1670 joules. Now we have to talk about the next part. Our next phase is liquid. Well, water is liquid from 0 degrees all the way up to 100 degrees Celsius. Sorry, that's not a straight line. Part 2 got in the way. So for part 3, we're talking about when the water is a liquid, because we got to get from cold water, 0 degrees, up to really warm water, 100 degrees Celsius. So for this one, we're going to use delta T, because there's a change in temperature. So we're going to use this equation, the first equation. So we have Q equals our mass. Our mass does not change during this, times our specific heat. Now, make sure that you guys use the right specific heat. We're going to use the specific heat of liquid, which is 4.18 joules per gram degrees Celsius. And then times our delta T. Our delta T is change in temperature. We started at 0 and went to 100. So that's a total change of 100 degrees Celsius. It's going to be our change. Sorry, I forgot my units on that one. Grams cancel out. Degrees Celsius cancel out. We're left with joules. We're good to go. Plug it into our calculator. 5 times 4.18 times 100, and we get 2,090 joules. So that's how much energy was required to heat the liquid up. 290 joules. Still not done. 2 more steps. Now we have to talk about the 5 grams evaporating. So we have to talk about this liquid becoming a gas. Notice how there's a flat line right here. That flat line is because it takes energy to go through a phase change. So we know there's no change in temperature, so we got to use one of these equations. Well, it's not going to be melting or freezing because it's at 100 degrees, so we're going to use condensation or evaporation. We're going to use Q equals mHv, heat of vaporization. So Q stays the same. 5 grams times our heat of vaporization, which is 2,260 joules per gram. Joules per gram. Plug it into our calculator. Our grams cancel out. 5 times 2,260. That gets us 11,300 joules. So that's how much energy it takes to evaporate 5 grams of water. Alright, we're at 10 minutes. I gotta move a little bit quick. I'm trying to keep it under 12. So, our evaporation was 11,300 joules. Now we have the last step, the gas. With the gas, the steam, we start at 100 degrees Celsius, and we're going to go up to 110 degrees Celsius, right here. So because we have a change in temperature, we're going to use this first equation. So, let's plug it in. Q equals mass, 5 grams times our specific heat. Make sure that you use the right specific heat. We're going to use 2.02 because that's when it is a gas. So we have 5 grams times 2.02 joules per gram degrees Celsius. Then our last step is to times it by the change in temperature. Our change in temperature was we started at 100 and went to 110 degrees. So that's a change of 10 degrees Celsius. So we can plug that into our calculator. 5 times 2.02 times 10. And that gives us 101 joules. So that's how much energy it takes to get from 100 degrees to 110 degrees of 5 grams of steam. Alright, we're still not done. The last thing we have to do is we have to add all of these up to get our total energy. So, plug it into our calculator, add them all up, and that gets us our answer. So 51.25 plus 1670 plus 2090 plus 11,300 plus 101 joules. That gives us 15,212.25 joules. So that's how you do your energy equations, all three. Now sometimes it's not going to be that simple as far as solving. We didn't have to solve for any other variables other than Q. You're also going to see equations where you have to calculate the specific heat. So for example, let's say it asks, what is, let's think, what is heat of vaporization of a substance that requires 500 joules to freeze 7 grams. So, for this one, it asks what is the heat of vaporization. So it's pretty obvious which equation we're going to use. We're going to use heat of evaporation. So Q equals mHV. Oh, I made a mistake. So I said heat of vaporization up here, yet I have freeze down here. So this should be, not freeze, this should be boil. Or evaporate, condense. So that's my fault. Sorry about that. Thinking on my feet didn't work out too well. So now we can plug it in. 500 joules. There is going to be our Q, our energy. So we'll have 500 joules equals our mass, 7 grams, times our heat of vaporization. We don't know what that is. That's what we're trying to figure out. So it's like solving for x. Divide both sides by 7. Plug it into your calculator. You'll get 70 point something. 71.4. And what are my units? Well, we can't cancel any of these units out, so we're left with joules per gram. So that's 6 equations on how to do energy. Hope that helps.